This is the video notes that's going to go with our guided notes rate of change word problem. Now, before we get started on the word problems, let's go back and just refresh our memories on prior knowledge. We have talked about rate of change being the same thing as the slope of a line. Some people will refer to it as the unit rate. It can be at times the constant of proportionality. Okay, so in previous lessons, we have talked about slope of a line, finding it three ways, finding it using a graph, using a table of values, and just using the formula. Okay, we're going to look at a word problem today that uses all three of these methods, one of each type. Okay, they're not going to ask you to find the slope. What you will be asked to find is the rate of change. But you have to understand that you're going to do the methods for finding slope to find rate of change also. Okay, now the other piece of information that's going to come in with the strategy for these problems is this. You're going to be given a situation, okay, some kind of real life situation that has a beginning amount and an ending amount. You're going to be told their values at the start and the values at the end. Once you find the values at the beginning and the values at the end, then you're going to pick your method up here to find the rate of change between those 2 points. Okay, so let's go ahead now and return back to our notes right here. And if you know, anytime in your notes, if you need to pause the video to copy it down, please feel free to. Okay, now example 1 says we're going to find the rate of change by using the formula. Okay, the situation we have here is a snowy tree cricket chirps 100 times per minute when the temperature is 65 degrees and 128 times per minute when the temperature is 72 degrees. Okay, so the first thing we're going to do is we're going to identify what is X and what is Y. Okay, what are the two things that they're talking about? Not the two numbers, the two items. In this case, the two items they're talking about is the number of chirps and the temperature. Okay, so every one of my points is going to have an X value that relates to chirps. The Y value is going to relate to temperature. Okay, now we're going to pick apart the sentences to find our combinations. Okay, so right here it says a snowy tree cricket can chirp 100 times per minute when the temperature is 65 degrees. So that means my first ordered pair is going to be 165. Now, I'm going over to the second part of this complex sentence to find my other pair of numbers. Right here it says I have 128 chirps when the temperature is 72. So my other ordered pair here is 128 and 72. Okay. Now, once you've identified your two ordered pairs, then we'll use the method requested to find the rate of change. This one requests that we use the formula. So our formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, all I'm going to do, remember, is put my 4 values in their correct spot. What we have to remember is that this is x sub 1, y sub 1, x sub 2, y sub 2. Okay? Now, let's put them in their spot. Y sub 2 minus y sub 1. That's 72 minus 65. Over. Now, x sub 2 minus x sub 1. That's 128 minus 100. Okay. Now, here we're just going to do order of operations. So I've got m is going to be equal to 72 minus 65, which is 7. My denominator is 128 minus 100, which is, of course, 28. Now, guys, remember, if it's a fraction, it has to be simplified. Okay, so 7 over 28 simplifies to 1/4. So m is equal to 1/4. What does that mean? That means for every 1 degree, the temperature goes up, the number of chirps, because x is chirps, will go up. So every time the temperature increases 1 degree, that cricket's going to have to work harder and faster because it's going to chirp 4 more times per minute. Okay, pause your video and copy this down. Okay, then we'll go to example 2. All right, example 2 right here says we're going to find the rate of change by using a table of values. So let's read our situations. In 1990, a public library had 16,000 books on its shelves. In 2010, the library had 19,000 books. Find the average rate of change in the number of books per year. Now, this comment right here tells me exactly what y and x has to be. Okay? Now, I'm going to stop here and explain something. That says books per year. That is books. Per is always a fraction line. Per, always a fraction line. It's a ratio. Year. Now, if we are using, I'm going to write right over here to the side, if we're using the table of value method, we are told that the slope is the change in y over the change in x. Well, if that's true, that means my denominator has to be the x value, which is years. My numerator, which is the y, has to be books. So books is going to be the x, and I'm sorry, the y, not to tell you backwards, and years will be my x. So now that I've cleared that part up, I'm going to go back into my problem and I'm going to look for those ordered pairs. So look at my first sentence. It says in 1990, the library had 16,000 books. So my first ordered pair, well, let's see, we're going to use a table, right? So let's go ahead and make a table. Our first ordered pair in our table is going to be 1990 and 16,000. Just like that. Now, in my second sentence, I see my next pair of numbers. It says in 2010, the library will have 19,000 books. So 2010, and we're going to have 19,000. Now, we know to use our table method, now we're going to look at our difference, our change. Sometimes people will say, well, what do you add to get the next number? Okay. What is the difference or the change between 16,000 and 19,000? Well, you know, you could actually just do a simple subtraction and go 19,000 minus 16,000, which is 3,000. Or you could just ask yourself, well, what do I add to 16,000 to get 19,000? Well, it's 3,000. 16,000 plus 3,000 is 19,000. So that's a plus. Now, look over here in the X. How is the years changing? Well, it started at 1990 and it ended at 2010. The difference between those 2 years is 20 years. Okay. Or I could say 1990 plus 20 is 2010. Oh my gosh, so many ways you can say this. Okay. Now that I have my change in Y and my change in my X, I can go ahead and put it in my formula over here. The change in Y is 3,000. The change in X is 20. And when with or without a calculator, 3,000 divided by 20 is going to be 150. Now, what does that mean? Go back right here, books per year. That means the library is getting 150 books each year. So that's my unit rate. It's getting 150 books each year. Okay, now pause your video and copy this down. Now, example 3 is obviously the third method, which is use a graph. Okay, so let's read through our information right here. At 1 p.m., a car passes a sign that reads Houston 90 miles. At 3 p.m., it passed a sign that said Houston 10 miles. What are the two things we're talking about here? We are talking about time and miles. Anytime, any situation, and anytime that you are talking about some kind of unit measurement of time, like hours, days, weeks, months, years, seconds, you know, if it's a measurement of time, centuries, decades, you're always going to let X be the time and Y be whatever else they're discussing. So here, time is going to be X. Okay. I'll write that right there on my graph. And X is going to be miles. Now I'll leave myself a little room right there because I need to put a scale in there. Now, let's come up with our two ordered pairs. At 1 p.m., the car passed a sign that said Houston 90 miles. So that's 1 p.m. and 90 miles. Now, my second sentence says at 3 p.m., we passed a sign that said Houston 10 miles. Well, so they've definitely gotten a lot closer to Houston. Won't be long before they get there. There's my second point. Now, when I look at my ordered pairs here, I see a problem. Not with the X, because the X's I can just count by ones. The Y's right here, though. Oh my gosh, I got to go up to 90. There is no 90 squares there. But if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I have 10 squares. I can scale my graph. Now, remember, when you scale a graph, you want to use as much of the graph paper as possible. You don't want to make it so big that you run off the paper, but you also don't want to make it so small that everything ends up right down in here and you've got all this empty space up here. So a perfect scale for this one is to scale by tens. So that's what I'm going to do. Just writing my scale in. Now, let's graph our points. Our first point is at 1 and 90. Now, notice I didn't put a scale down here. I can if I want to, but I'm not because I don't have to. Anytime you count off by ones, you don't need to write a scale, okay? Because if you don't see a scale, it's understood to be counting by ones. Okay, so 1 and 90. 1 and 90 right here. And then I'm going to go to 3 and 10. 1, 2, 3, and 10. Okay. I'm going to grab my ruler right here. And I'm going to connect those dots. Okay. Now, oops, a little bit past it. Now, do you remember that when we're doing the graph, we think about the slope as being rise over run? That's our hint if you're looking at the graph and looking at the rate of change or slope. So this is definitely a negative line because I started way up here and I ended down here going left to right. So I'm going to draw my little right triangle right underneath it because it's a negative. Just like that. And then I'm going to count. What is my vertical difference? Now I got to be careful. I can't just count lines because what is my graph scaled by? It's scaled by tens, isn't it? So watch what I'm doing. I start up here, 10, 20, 30, 40, 50, 60, 70, 80. So it goes down 80. So I'm going to write it right up here. Right, squeeze it in there. So it's negative 80. Now, if I go across, I am counting by twos, by one, so that's 2. Sorry about that. Now, over here, my rise is negative 80 because it actually went down, not up. Over, right here, it went to the right, 2. Now, if I simplify that, negative 80 divided by 2 is negative 40. Just like that. Now, what does that mean? That means I'm getting 40 miles closer every hour. Because if you get 80 miles closer in 2 hours, that means you're getting 40 miles closer every hour. Okay? Again, think about your slope like your unit rate when you did proportions last year. Okay? Now, go ahead and finish copying your notes and get them into your interactive notebook, and then go to Canvas and find your assignment and complete the word problems.